Welcome to lab. Today we're going to do the copper cycle. Please follow along in your lab manual. I'd like you to be my lab partner. The first two instructions say to set up the gas trap. So we're going to do that. First, we're going to attach a clamp, and we're going to be adjusting these later. And we're going to attach another clamp to the other ring stand. This is going to be our gas trap. And it says to put about 150 milliliters of tap water in there. I'll do that. And we will insert this into our clamp. Make sure it's tight and doesn't move around. That's good. And next, we're just going to test out our height. We're going to attach a clamp to the top of our tube. And then we'll need to position this bulb over the top of the test tube. And at the same time, it needs to be subsurface in our gas trap. Okay, so we're going to move these a little bit closer together. And then I'm just going to change the pitch and position of this. I can move it up a little bit too. It doesn't have to be a tight fit, but it should be over the top of the test tube. So what's going to happen in this test tube, we are going to have some toxic gases formed, NO and NO2, and through vacuum they'll be pulled into the gas trap, subsurface, and they will react with the sodium hydroxide that we're going to put in here. The first thing we're also going to do is to hook up an aspirator. And an aspirator is just a fancy word for a vacuum. And how we're going to do that, we're going to hook this where we want to get the vacuum in our flask to the side arm of the water faucet. Now, this is Bernoulli's principle. Water is going to be flowing over this part, and when it gets constricted to a smaller part, it will create a vacuum, and that's what we'll be using. So this is a little trick that we use in lab. This is a very large diameter hole, and this is a smaller diameter. I'll put them inside each other. And now I've got a small diameter connection to a large diameter connection. And we can get a tight seal on both sides, which we will need for vacuum. And we're just going to test it. Does it work? We're going to turn the water on. And if you see bubbles in your gas trap, your aspirator is working perfectly. I believe it also says about 10 milliliters of sodium hydroxide in the gas trap. We're going to do that. And again, it doesn't make any difference how, that it's exactly 10. Get around 10. That will be plenty to neutralize the toxic gases that will be formed in this reaction. And again, I'll put this in here. And once again, we will turn on our aspirator, making sure that it works just fine. It does. And we're going to leave this on through step 4. The next step we're going to do in the middle here is we're going to take a piece of copper and we're going to weigh it at the balance. Now that we've weighed our piece of copper, we can add it to our test tube. We're also going to add 2 boiling chips, and these just promote smooth boiling, which is very important here. The boiling can kind of be erratic. And the next step is step 4. We're going to be adding 10 milliliters of nitric acid. Now the nitric acid, you can see in your first chemical equation, will react with the copper, forming copper nitrate, nitrogen dioxide, and water. Again, the amount of 10 milliliters does not have to be exact. We're going to add the nitric acid to our test tube. Again, you need to be absolutely sure the aspirator is working. You can start to see the initial reaction of the copper with the nitric acid. And the next thing we're going to do is gently encourage this reaction to go a little bit faster with some heat. We'll use the Bunsen burner. Again, we'll first shut off everything. Open up both the gas flow and the airflow 1 turn. Hook it up to our supply. Always give your striker a test. And then we'll turn the gas on at the supply. And that's a pretty high flame, so let's adjust that. We're going to adjust that with the bottom knob, which is our gas flow. And then we know that we need a blue flame. We're going to give it a little bit more air, try to get rid of that yellow. And there we go. We've got a nice, hot, and clean flame. You can already see copper nitrate is starting to form. It's a beautiful blue color. And we're going to heat this gently. You don't want to get too much foam on the top, too much bubbling, because we don't want it to bubble over into our gas trap. We lose some yield there. So once you start seeing a lot of foam, you can just remove the Bunsen burner for a little bit. And we are going to heat until all of the copper is dissolved and our toxic gases are no longer present. And you can see the toxic gas. It's the brown color on the side of the test tube. It will be quite a bit more apparent in a minute. Our final solution should be a very beautiful blue color, and there should be no brown gas on the sides of the test tube. The green color of the solution is due to the toxic gases that are present, dissolved in the solution. you'll see we're forming a lot more toxic gas. You can probably see the brown color on the side. I'm going to just back the heat off a little bit. Seem to get a lot of boiling right now. And when that foam subsides, I'll add heat again. And I'll just continue the process until that piece of copper is dissolved and all the toxic gases are no longer present in the test tube. You can see there's a pretty violent reaction between the nitric acid and the piece of copper. We still have toxic gases on the sides of our test tube present, and the solution still has a greenish tint to it. We're not done. Got to get it boiling a little bit more to get those brown gases out of solution. You can still see them present on the sides of the test tube. I'm starting to see less and less of the toxic gas on the side of the test tube. And our solution is becoming blue. And I think that should be good. And we'll turn the gas off at the source. We've got a beautiful blue solution of copper nitrate now. We're just going to let this cool in the test tube, and we can also shut off the water at the aspirator, and we can continue on with step 5 when we're cool. Step 5 states to transfer this solution to a 250 milliliter beaker. There are some boiling chips in here, and we don't want to transfer the boiling chips. So what we're going to do is transfer them, but we're going to have the stirring rod blocking their entrance into the beaker. And if you do get a boiling chip or two in there, that's okay. We can fish it out, which I just did. And you'll always want to rinse your test tube because it does contain some of the solution, which contains our copper nitrate. And we will remove our boiling chips. Here's our first boiling chip that we're removing, and the second one. As you can see, they're a little bit difficult to remove, so it's always best if you try to trap them before they get into your beaker. I'm going to rinse my stirring rod right into here. And now I've got my copper nitrate solution in the 250 milliliter beaker. And then it says to dilute it with DI water to about 50 milliliters. Just a general marking on the side of the beaker. And I've done that now. Now in step 6, it says add 20 milliliters slowly with stirring of sodium hydroxide, and I've already put this in the graduated cylinder. So very slowly I'll add this, and you'll see that we're now making the beautiful blue solid copper hydroxide. And then I'll rinse the stirring rod off. Again, rinsing all of the copper hydroxide that may be attached to the stirring rod into our beaker. In step 7, we'll add some more DI water, about 80 milliliters. So our total volume is perhaps 150 milliliters. Again, the volume is not terribly important. And now that we've done that, we can put our beaker on the hot plate and turn it on. We'll put it on medium-high, and we're going to be stirring. With the addition of heat, the copper hydroxide will become copper oxide, which is a black solid. This step often takes quite a while. Our solution is starting to turn black now, and that black precipitate is copper oxide. Another piece of technique that you'll need to do is you might notice on the sides of the beaker, since we've been stirring, there's been some solution and some copper hydroxide has been kind of attached to the side. It's always a good idea to use a wash bottle and wash the sides down once this black copper oxide starts to appear. There's still a green tint, blue-green tint to the solution, so we'll continue to stir and heat. We're going to continue to do this until all the copper oxide has precipitated and we cannot see any more of the blue-green solution. And most of what I'm seeing on the side is now the copper oxide, the black precipitate. So once you start seeing a lot of that, you don't need to wash the sides of the beaker down as much. We'll just go another minute or two. Okay, it looks like we're done. I'm going to rinse the stirring rod off into the beaker. And I am going to shut my hot plate off, and then I'm going to remove the beaker with a mitt to the bench top. Now a process is occurring right now called digestion, where smaller particles of copper oxide will dissolve and they'll reprecipitate as larger particles, which will be much easier to filter. We're going to wait until that's cool, and while we're doing that, we'll be able to do step 8, preparing for filtration. We're now in step 8. It says to discard the contents of the gas trap. So I'll take off my hood and aspirator setup and then remove the Erlenmeyer flask. The manual says I can dispose of this in the drain. The next thing I'll do is I'll prepare for gravity filtration. This means filtration just by gravity, and we'll be using this funnel. The other type of filtration is suction, which we'll be using later. I have a piece of filter paper. I'm going to fold it in half and then in half again, so it looks like the shape of that cone. Then I'm going to open it up so that one thickness is on one side and 3 thicknesses are on the other side. So it forms a nice trap. I'll put this in my funnel, and then I'm going to wet the funnel with a little bit of water so that it adheres to the sides. You can kind of push that down a little bit. And we'll just lay the filter in the Erlenmeyer flask. We're now in step 9. Our solution that contains the solid copper oxide is cool enough to handle, and we're going to transfer this quantitatively through the filter to the Erlenmeyer flask. And the filtrate, which is the liquid, will end up in the Erlenmeyer flask, and the copper oxide will be in the filter. Now, it's not necessary to get all of the copper oxide. You'll see there's probably quite a bit that will remain in this beaker. We don't need to totally get every single molecule into the filter. And I'll show you how that we can address that in the next step. We will get all of it, so our yield will be good. And we'll keep on pouring. Again, you'll see that there's quite a bit of copper oxide left in this beaker. I'm going to wait for most of the filtrate to be removed from the filter and copper oxide, and that's pretty good. The end of step 9 is probably the most important step in the procedure and where I see the most mistakes. It says to discard the colorless filtrate. This is the colorless filtrate, and we need to get rid of that, and it's okay to get rid of that right down the drain. If you do not get rid of this, you have to start over, I believe, at step 5 again. I'm just going to rest the filter in the beaker while I get rid of the filtrate. And now I'm ready for the next step. Now we're in step 10 of the procedure. I've obtained 30 milliliters of hydrochloric acid in this graduated cylinder, and I'm going to slowly add it to our filter. And when I do that, the copper oxide will react with the hydrochloric acid, forming copper chloride. Copper chloride is a green solution. Now I'll wait for most of this to get through, and I am just going to be pouring back and forth between the Erlenmeyer flask and the beaker, targeting different areas of the filter paper or the beaker so that all the copper oxide is converted to copper chloride. I'll bend this in a little bit to try to get copper oxide up on the top of the filter. There's one piece of copper oxide that I see on my filter. I'll try to target that. I got that. And then I'm also going to roll and maybe just stop for a minute, kind of roll this and roll the solution, it's mostly hydrochloric acid, on the sides of the beaker. I should probably do this over the filter. Sometimes you need to pause for a little while for it to react. Okay. Just to get every last drop of that copper oxide reacted to copper chloride. Got one last piece to go, and then I'll be good. All right. Now eventually we want to be in our beaker, because that's where we will precipitate the final copper. Again, I'll put it back through the filter. And then we're going to rinse this filter paper down quite well with DI water to get every last bit of the copper chloride into the flask, and then we'll eventually put that into the beaker again. So you might see the green on the sides. I'm just going to wash all of that green, so I no longer see it, into the Erlenmeyer flask. I think that's sufficient. We'll let it drain. And I'll transfer this and maybe just a little bit more DI water, rinsing the flask out. In our next step, we're going to put some zinc on a piece of whey paper. Just going to fold it in half again so that the paper does not lie flat, and I can easily move it. I can put a little bit of zinc on that paper. Now that we have obtained the zinc, we can precipitate the copper 2+ ion as copper. Now, on this black bench, sometimes it's hard to see when our solution has no color in it, so I like to put a piece of white paper underneath. I'll add a little bit of copper, zinc. I'll add a little bit of zinc. And with some stirring, we'll start to see that our copper is precipitating. Sometimes you may need to use a little bit of water or the solution to get any of that zinc in the solution so that it can react with the copper. And we're starting to lose a little bit of our color. And it appears that I'll need some more zinc. It's still reacting. You can kind of see that with all the bubbles that are in solution. And our solution is losing even more of the color. Let's let that react for a little while. Our solution is essentially colorless. I've still got a lot of bubbles occurring. So to address that, I'm going to add just a little bit of hydrochloric acid. We'll just wait a little while longer for everything to stop bubbling, and then we can transfer this to our Buchner funnel. Now in step 12, we'll set up our Buchner funnel. Here's our Buchner funnel, and we'll just put it in the top of the Erlenmeyer flask. And we'll need to apply suction, but this tube is too small. So we'll use the trick that we used previously, and we'll put a larger diameter tubing over the smaller diameter, and then we can insert the larger diameter tubing to the side arm of this large suction flask. And we will turn on our water. Again, that will give suction in this flask. We're also going to obtain a piece of filter paper for the Buchner funnel and a watch glass. We're going to mark our initials on the paper in pencil. If we did it in pen, they would dissolve at the very last step because we will be adding acetone. And we're going to go weigh this. I'll put the piece of filter paper with our initials down, and then just wet the piece of paper with DI water. Maybe press down a little bit, and you'll see that the water is now in your flask. In the next step, we are going to quantitatively transfer our copper, which is now precipitated and all the bubbles have ceased. We're going to put that in the filter, we're going to pour quite slowly so that the copper ends up in the middle of the paper. And we'll use the rubber policeman to kind of get most of our copper out. Be sure to rinse your rubber policeman with a little bit of DI water if there's any copper left. And just give, I see one piece of copper still left in here, the inside of your beaker a rinse. We'll break up any large chunks of copper with the glass end of our stirring rod. And then be sure to, you can rinse it off. You'll see that there's quite a bit of copper that stuck to the end of that stirring rod. And now when nothing comes through, I'm going to add acetone. That's in our red top bottle. And what we're doing here is we're replacing a lot of the water that's kind of stuck to the copper with acetone. Acetone has a lower boiling point than water. So when we put this in the oven, it will dry much more quickly. I am just going to let that kind of come through for a little bit. And you'll see I've got my copper on the filter paper. Filter paper is already starting to dry from the suction. And when you can't smell acetone anymore, it's okay to turn off the aspirator. And then we will remove the filter paper with the copper on it to the watch glass. This is how we're going to do it. We'll put the watch glass over the top of the Buchner funnel. And if sufficiently dry, when we flip it over, the filter paper and the copper should be on your watch glass now. And there's a little bit of copper there. You can just kind of get that in. Nothing else is left. And again, I'm going to use acetone. It has a lower boiling point than water. Just a little bit is fine. To rinse off any of the copper that's stuck to my stirring rod. And I'll place this in the oven. Now let's open the oven and put in our sample. And we'll let that dry in the oven for about 10 minutes before we check the weight. Now that our sample is at a constant weight, you can calculate the % yield from your data. Thanks for being my lab partner.